Hi everyone, my name is Alex Markin and I am from the Rhode Island Intensive Math Intervention Project. Thank you so much for joining me today. Today we are going to be discussing effective instruction to support students' language development in your mathematics classroom. While the strategies are effective for all of your students, we have defined which ones are particularly important for your English learner or EL students in the top left-hand corner of the slide where applicable. The content from this training was informed from a variety of resources that you can find at the end of this presentation. Before we dive into the content, we are going to start with a brainstorm pre-activity. Think about a unit or lesson that you taught recently. What vocabulary did you teach your students? What instructional strategies did you use during the particular lesson to teach the vocabulary terms? Try to create the most comprehensive list possible, as this will become an inventory that you can refer to throughout the school year. You can complete this activity individually, but it would also be interesting to discuss your list with your fellow grade level teachers. Please complete this activity now, so pause this video until you're ready to proceed. Today we are going to learn about the importance of language and vocabulary in the mathematics classroom. We are going to discuss word problems, which are frequently identified by teachers to be an area of difficulty for students. We will also briefly review several instructional strategies to teach vocabulary to students, including explicit instruction, graphic organizers such as the Freyer model, sentence stems, and total physical response or TPR. We will be starting with the language of mathematics to better understand why language can make mathematic content inaccessible to students and what we can do to better support language development in the mathematics classroom. It is important to remember that all students are mathematical language learners. For our students who are ELs, it is also important to remember that they are in the process of learning 3 languages: their primary language, English, and the language of mathematics. Unfortunately, language can make math inaccessible to some students. As we will describe in the coming slides, there are many attributes that make math language inaccessible. First, there are words with multiple meanings. For example, a table is something that you sit at. It can also refer to a chart with rows and columns. And there is the expression, let's table that for later. Second, there are words that have different parts of speech depending on the context. For example, a square can be a noun to refer to the shape, a verb to refer to the act of squaring a number, or it can be an adjective to describe an object, such as the square backyard. Third, there may be words that sound similar to those in students' primary languages, but actually do not mean the same thing, known as false cognates. Fourth, there are different ways of reading math problems depending on how they are set up. Some you read from left to right, others from right to left, and some from top to bottom. Math does not always follow the left to right pattern seen when reading English. For these reasons, and many more, all students need abundant opportunities for listening, speaking, reading, and writing in the mathematics classroom. The assumption that math is a universal language can lead educators astray, as they may incorrectly assume that all students can succeed in math regardless of their language proficiency. After all, numbers are universal. However, we interact with the language of mathematics in a variety of ways: through words, such as add, subtract, reduce, through numbers, including both positive and negative numbers, through symbols, such as operations, parentheses, and brackets, and we can read a problem in a variety of ways, from left to right, right to left, and from top to bottom, depending on how the problem was presented. All of these require a command of the English language that not all students have yet. Because the language of mathematics is so complicated, it is important that we use clear and precise language. Students need to learn an accurate mathematical context that will provide them with a solid foundation. On this slide will be common examples used in classrooms that highlight the need for more precise mathematical language. None of us are perfect, so if you have used any of these yourself, make a note and try the alternatives suggested next time. For number 1, by referring to a digit as a number, we are not helping students understand place value. For example, 456 is a number. The 6 is in the ones place, and it is a digit, not a number. Teachers should explain the difference in the value of a digit versus the value of a number so that students are clear about the vocabulary and code switching required to solve the problem. In number 2, we often use equals to indicate that students should write an answer to the problem. However, the term equals has a precise mathematical meaning, the same as, and by using it in this context, we are reinforcing that the quantities on both sides of the equal sign should be the same. Number 3, reading a decimal as point does not help students understand magnitude of the place value. Instead, read the decimal as 4 7/10, which reinforces both place value and magnitude. Number 4, using the terms carry or borrow is procedural. By using alternatives such as regrouping, trading, or exchanging, we are reinforcing the conceptual understanding of regrouping ones into tens, tens into hundreds, etc. Number 5, by referring to a numerator as the top number or the denominator as the bottom number, we are treating a fraction as though it is composed of two separate and independent numbers. Instead, use the technical terms to refer to the different parts as both contribute to one number, the fraction. Number 6, reduce suggests that the result is less in quantity. However, the magnitude of the fraction does not actually change. The change is in the digits that are used to represent that magnitude. Number 7, referring to two shapes as being the same is too vague. Instead, use the more precise technical term congruent, as that describes that the two are the same shape and size. Number 8, the use of the word long is not mathematically correct. Instead, say the length of the side is 4 centimeters. And lastly, there are many rules that change in later grades. Examples include multiplying by two numbers always results in a larger number, or dividing two numbers always results in a smaller number. These rules will change when students are introduced to zero and negative numbers. Since these rules can cause confusion to students as they progress through schooling, we need to explain them accurately in earlier grades. Students need to know the practical definitions that they will frequently encounter in mathematics. While having rich mathematical discussions are important, you should not assume that these conversations will automatically lead to a knowledge of a math vocabulary term. In order for students to understand math vocabulary, they need to have multiple opportunities to hear and interact with the word. In this section, we will discuss which words you should target for teaching in your math classroom. Students' knowledge of words determine their ability to comprehend the text. This is especially true for our struggling learners. The selection of vocabulary terms to teach students can be grouped into 3 tiers. Tier 1 words are particularly important for our ELs, as English proficient students are likely to be familiar with these terms. With Tier 1 words, ELs are likely to know the term in their primary language, but not know the label in English. Tier 2 words are important for all of our students to know. They are more complicated than Tier 1 words and appear in grade level text and assessments. Tier 3 words are those that students are unlikely to encounter in their everyday life. These words are content specific, such as polygon, and will need to be taught to students. We will dive further into these tiers over the next several slides. Tier 1 words should be taken into consideration for all of our students, but are particularly important for our ELs and at-risk students. Tier 1 words are those that are key to understanding the passage or word problem. Since ELs usually know the word in their primary language, these words can be easy to teach. Visuals and actions are quick ways to represent many Tier 1 words. For example, with the word square, we have the translation in Spanish and a quick visual. Later in this presentation, we will be discussing graphic organizers, such as the Freyer model, and total physical response, or TPR, as 2 instructional supports that work well with many Tier 1 words. However, some Tier 1 words cannot be easily represented. For example, the word uncle. In this case, a quick explanation would often suffice, such as the brother of my father or mother, or a translation into the student's primary language, el tío, in Spanish. Other Tier 1 words include idioms and common expressions. Again, native English speakers are usually familiar with these, but ELs would need to have these phases explained. Simple cognates are also considered Tier 1, such as family and familia in Spanish. In the mathematics content area, many cognates are considered to be Tier 2 vocabulary words, and we will be discussing these shortly. Tier 2 words are more complex and abstract than Tier 1 words. They appear in grade level text and assessments and are critical for students to understand the text or the general concept being taught. Tier 2 words may already be identified in the curriculum that you are using. However, keep in mind words such as justify, compare, reflect, explain, order, etc. These words are often not included in math vocabulary lists, and we can accidentally assume that students are familiar with these words when they are not. Without understanding these words, students will not know what the problem is asking of them. Different Tier 2 words require different instructional strategies. Some can be seen visually, many are cognates, which we will discuss shortly, and many can be targeted for pre-teaching. Words that should be pre-taught are those that cannot be easily demonstrated and are not cognates. For example, the word me. It is important that teachers model using these words and provide students with opportunities to repeat both the word and the definition. Students should also have opportunities to practice using the word themselves. For example, when reviewing the word traditions, students could have a chance to discuss different family traditions. This is also a culturally and linguistically responsive practice. With Tier 2 words, students must be flexible with their use of language. Students may understand the general concept, but need greater precision and specificity for how it is used in specific contexts. Homonyms are words that are spelled the same but have different meanings. A good example of this is in the first column, the word mean. Students may be familiar with the first definition, which is to be not nice, but not the second, which is specific to mathematics. All of the examples in this table have meanings in general English and specific uses in mathematics. Other examples of homonyms with math definitions include factor, left, round, foot, base, area, even, rational, product, and many more. It is important to be aware of homonyms, as they can be confusing to students if they do not know all of the various definitions of one word. The use of cognates is a strategy that is specific to ELs whose primary language shares cognates with English. For example, 30 to 40% of all words in English have a related word in Spanish. It is important to note that this strategy will not work with all languages. Mandarin has few cognates with English. Educators should know that it is a myth that making connections between students' native language and English will cause them confusion. Rather, the native language can actually serve as a foundation for English language and literacy development. In this table are examples of math cognates in both English and Spanish. As you can see, these words have a similar spelling and pronunciation and have a common meaning. However, teachers need to be aware of false cognates. False cognates look similar, but do not have similar meanings. These are words that may be confusing to students. For example, pie in Spanish means foot, but is a type of dessert in English. For another example, embarazado in Spanish does not mean embarrassed. It means pregnant, but you will be embarrassed if you use embarazado incorrectly. Involving students in the identification of cognates is a wonderful way of treating their first language as a resource. Students can have an active role in identifying cognates and documenting them in the classroom. It is important to remember that there are different stress patterns between English and other languages, such as Spanish, which can cause confusion for ELs. Be explicit in discussing the pronunciation of words. It is also critical to discuss false cognates to avoid confusing students, as we discussed on the previous slide. Tier 3 words are primarily found in content books. These are words that students are unlikely to encounter in their daily lives. All of these terms are specific to the language of mathematics. They will need to be explicitly taught to students. For ELs, a bilingual dictionary in their primary language is a useful resource. On this slide are several examples of Tier 3 math vocabulary terms, such as quadrilateral, decimal, and divisor. What makes word problems challenging for struggling learners? Word problems require that students read and comprehend the problem, are able to identify the problem that needs to be addressed, and create and solve the equation. In this section, we will discuss word problems and instructional strategies that we can use to support students. ELs are unlikely to possess a level of background knowledge that is similar to fluent English speakers. Therefore, teachers will need to provide additional support and instruction to their ELs. This is particularly pertinent to word problems, as problems often use real-life context that may not be related to students' lived experiences. In these situations, students may need a clear and concise explanation of the scenario or a visual representation that is not directly related to mathematics, but to the broader context. Teachers should not rely on students to identify unfamiliar contexts, as students may be self-conscious or may not yet be aware of what they do not know. For example, a real-life problem may discuss budgeting for a family vacation. The concept of budgeting for a family vacation may not be familiar to or relatable to some students. A more realistic situation may be budgeting to go grocery shopping in order to feed their family dinner. To enhance this instruction further with culturally and linguistically responsive practices, the teacher could incorporate knowledge of students' families by bringing in advertisements from local grocery stores where students likely shop and discussing the foods and items that their families purchase. These types of modifications can be incorporated strategically into lessons where appropriate. To better illustrate the need for background knowledge and how background knowledge applies to word problems, consider this example. I will give you a few seconds to review what's on the slide. This word problem involves real-life application. However, there's context in this problem that students may not be aware of. Specifically, the concept of having a lemonade stand and the act of donating money to charity may be unfamiliar to some students. To help these students, it is important to review these unfamiliar contexts. For example, providing some visual pictures of a lemonade stand and explaining what one is may help students. The Institute of Education Sciences Practice Guide, which is linked on this slide, have 5 recommendations for teaching word problems to students. Number 1, word problems should be incorporated into whole class discussion, not just saved for individual work or for homework. Teachers should consider students' background knowledge and their interests when selecting word problems. Number 2, students should be provided with opportunities to think through and reflect on the problem-solving process. Posing questions such as, what is this problem asking me to do, will help students master complex problems. Recommendations 1 and 2 should be used regularly when preparing lessons. The upcoming recommendations 3 through 5 do not have to be present in every single lesson. Teachers can choose the recommendation that best align with their goals for this particular lesson. Number 3, visual representations, including tables, charts, graphs, and diagrams, should be used to help students focus on the information that is central to the problem, the relationship between quantities. Number 4, teachers should share multiple strategies that can be used to solve a problem. Students should have opportunities to communicate their thinking through sharing, comparing, and discussing strategies with their peers. This will help students become increasingly flexible in their approaches. Struggling students can often become too reliant on one strategy and then flounder when that strategy does not work. And lastly, number 5, teachers should help students recognize and articulate mathematical concepts and notations. Students' problem solving will improve when they have a better understanding of the formal mathematics underlying each problem. This is the final section of this learning module. In this section, we will discuss various instructional strategies that you can use within your classroom to support students' language and vocabulary development. First, we will discuss explicit instruction. Then we will look at graphic organizers and sentence stems. And lastly, we will discuss total physical response, or TPR. There's a lot that goes into these instructional strategies, so this is truly meant to be an overview. If you are not currently utilizing one of these strategies within your classroom, you may look to research more. Now that we know what makes the language of mathematics complicated, let's discuss the instructional strategies that teachers can implement to support their students. Explicit instruction is an instructional practice that is defined as being research-supported instruction that provides needed supports for successful student learning through clarity of learning and purpose and reduction of students' cognitive load. Explicit instruction promotes active student engagement by requiring frequent and varied responses, followed by affirmative and corrective feedback from the teacher. There are 16 elements of explicit instruction that are on this slide, and they describe 6 key principles. Number 1, we want to maximize students' engagement on a task. Number 2, we want to promote high levels of student success. Number 3, we want to maximize instructional time or increase the amount of content that we are able to cover within our classrooms. Number 4, we want students to spend more time in groups where they are able to receive more targeted support from the teacher. Number 5, we want to scaffold instruction and systematically fade these scaffolds as students are ready to promote independent learners. And lastly, number 6, we want to address different forms of knowledge so that students can express their knowledge at different levels, including the declarative level, which is when they describe what something is, the procedural level, which is when they describe how something is done, and the conditional level, which is when they describe when and how and where to use the skill. Sentence stems provide students with a framework to use the new vocabulary that they are in the process of learning. Two types of sentence stems include sentence frames and sentence starters. Sentence starters are more open-ended than sentence frames. On the next slide, we will watch a quick video of a teacher explaining her use of sentence stems within her ELA classroom. These supports would look very similar in a mathematics classroom.
A sentence frame is something that scaffolds for English language learners. It's actually an entire sentence written out where students only have to fill in parts of information that complete the answer. For example, for drawing conclusions about characters, we used Andrew is blank. I know this because the text says blank. So students might say, Andrew is helpful. I know this because the text says he stopped to help the girl pick up her books. This helps students not worry about expressing their thought in English. That part is taken care of for them. All they have to do is go through to the text and isolate the actual answer and plug it in, so that sort of takes away, they're sort of navigating through two skills there. It isolates one, which is the drawing conclusion part, and lets the English part is done for them. And it also scaffolds their English language development.
The Freyer model is one instructional method to help students analyze mathematical terminology. It can be used across grade levels, content areas, ability levels, etc. Since this is a physical product, students will be able to refer to it throughout the school year. Students should have some familiarity with the word before beginning this graphic organizer. In a Freyer model, students write the term in the center circle and then complete the 4 quadrants, defining the term both formally and informally, identifying facts and characteristics about the term, and providing examples and non-examples. There are multiple ways to complete the Freyer model. One option is to start with the examples and then move to describing the facts and characteristics based on the examples. After determining the characteristics, the student then moves on to defining the word. Struggling students can have difficulties with determining the characteristics and may repeat the definition a second time in that quadrant. Presenting the information in this manner can help prevent that. Lastly, you would discuss non-examples. In non-examples, we want objects that are as close to what you are trying to show as possible, known as minimal pairs. For example, a hurricane is not a good non-example of a square. Students may need to be shown appropriate non-examples. Struggling students may need the Freyer model to be adjusted further. For example, a quadrant can be truncated or renamed depending on students' needs. For example, instead of defining facts and characteristics, a student can draw a picture demonstrating the abstract word. It is also possible to have some of the sections already completed for students. Total physical response is a physical representation of language. Rather than having students repeat a new word, they repeat the word and engage in a physical action that represents that word. Students can be actively involved in creating the movement that will accompany the vocabulary term, or you as a teacher can determine the action. On the next slide, we are going to watch a quick video of a teacher using PPR within her mathematics classroom.
And then all of a sudden it goes really fast. Okay. Okay, so
There are some things you need to remember for our activity today. You need to know this thing.
Plus sign.
Plus sign. When you see a plus sign, what does it mean? When you see a plus sign, what are you doing with your numbers? Tessa?
Putting them together.
Putting them all together. Your turn.
All together.
We're putting them all together. That's important to know. You also need to know this.
Minus
sign. What does a minus sign mean? What does a minus sign mean?
Take away.
Take them apart. Your turn.
Take them apart.
Excellent. And you also need one of these.
Equal sign.
An equal sign. And an equal sign acts kind of like a scale. It has to be the same. It has to be equal on both sides. Are you ready?
Yeah.
Okay. Think real quick. What does a plus sign mean? Turn knee to knee with your partner. You guys are going to be a group of 3. What just happened? Brianna, come scoot over by Josias real quick. Just stand up and move over. Leave your stuff. Just go sit by him. There you go. You guys will be partners. Have a seat right there, right on the ground. Perfect. Okay, plus sign. I would like you to real quickly, Snow, tell Flakes, what do you do when you see a plus sign? Go. Just Snow.
Put them all together.
Sit straight, please, so that
We have covered a lot of content in this learning module. In summary, a few key points for you to take away. The language of mathematics is more complicated than you think. It requires explicit teaching, frequent practice, and modeling of vocabulary terms across the 3 tiers. It should also include technical language and precise explanations that will not cause students confusion as they progress through their schooling. And it can be supported by visual representations, actions, and students' primary languages. We want to remember, particularly for our EL students, that their primary language is a resource that can benefit them in the mathematics classroom. Now that we better understand the use of language in your mathematics classroom, let's return to the brainstorm activity that we completed at the very start of this learning module. Review your list of instructional strategies that you have used recently in your classroom to support students' language development. Is there anything you forgot to add but use in your classroom that we discussed today? What from this presentation was new to you? If you learned about a new instructional strategy or support in this presentation, we would like for you to plan on implementing that strategy within your classroom. Think about your upcoming lesson. Which vocabulary terms will you need to teach? Which instructional strategy is the most appropriate for these vocabulary terms? If you do not already use the Frayer model within your classroom, it is a good starting point as it is easy to incorporate into your instruction. We have provided 2 blank versions of the Frayer model, the traditional version with facts and characteristics, and the modified version where students draw an illustration. These are available in both English and in Spanish in the Implementation Resources folder. These are my colleagues on the Rhode Island Intensive Math Intervention Project. You may see one or more of them at your school throughout the school year, and if so, make sure you say hi. This learning module was informed by a variety of articles, books, and websites, all of which are listed below. I've also identified a few helpful resources that you may not be aware of. Wordsmith.net is a useful website that provides student-friendly definitions at a variety of proficiency levels, including beginner, intermediate, and advanced. Colorin Colorado is a bilingual website with many free resources. Several articles were used from their website in the creation of this learning module. The Math2 website provides English math terms and their Spanish translations. This may be useful to you as a teacher in identifying Spanish-English cognates and for your students who are native Spanish speakers to provide translation support. Lastly, the Problem with Math is English may be a good addition to your library to dive into this topic more deeply. This concludes our learning module for today. Thank you so much for joining me, and I hope that you learned something from this presentation and are excited to implement it within your classroom. Thank you so much.